We will now move on to the questions and answers sessions. To remind the audience online, you can use our website to actually post questions online. We're now going through them. Also, the Zoom participants, you're invited to post questions in the chat now. So let me start with Cecilia, maybe. Are you expecting something like a domain shift depending on the hardware that is used to record the cough or the environment that participants would record their symptoms with?
Sorry, I missed one word. Are you expecting?
Something like a domain shift, like, yeah.
I essentially, I don't know yet if this is possible. I think we are dealing here with data that is probably, it's in the wild, right? Unlike something that is detected in specific situations where the user is in an unnoisy location. This is in their house or in their environment, and I think there are additional challenges there. But I think this could lead to possible indications of perhaps something that should be looked into. We will have perhaps false positives, and it's a matter of understanding if these are significant.
Mm-hmm. Then a question on the telerobotics. Are you planning to use deep reinforcement learning at some stage with this project? And if so, how would you envision it to work?
Okay, we don't have that currently in our plan for doing reinforcement learning. We are looking, of course, at doing things using computer vision to identify the buttons. But I think that we expect that we should be able to do that without needing to use reinforcement learning, though I certainly wouldn't rule it out. I don't know if my colleagues Russ or Axel have anything to add to that.
I could comment on that. First, you don't really have much data right now. I think the goal is to get something that's deployable quickly. Now, one of the things clearly that you can do with once you've deployed it is you can record everything you do. In fact, I'm sure you will want to. And that may become useful, certainly in cases where the robot seems not to be doing what the human wants, and then the human will obviously have a way to stop the robot from turning off the ventilator or whatever. So there's a use there. I think more broadly, this is sort of this isn't the first crisis we're going to have. What I personally believe is that we should be able to use the experience, in fact, this entire community mobilizing all over the place, to draw some lessons for what we can have in place to make the next generation problem able to be responded to more effectively. And with robots, we're dealing a lot with human-robot partnerships and a three-way partnership between people, the technology, and information to help with processes. And I think that as the research goes forward and we get this experience base down the line, I think we're going to see those coming together. But the goal here is just to get something deployable as quickly as we possibly can to address a real problem.
So how fast do you think such systems would be actually deployable?
Well, we need to get the prototype working. I'm hoping that, and we've almost, Peter, I mean, what are your thoughts? You're more conservative than I am.
Well, I mean, you know, we have to get, of course, the appropriate approval from the hospital to be able to even try it with patients. So I think we can do that by July. That was just a few deployments, not large scale deployments. We haven't really
the idea is
come up with a timeline for that.
I'm sorry, Peter. The design,
no, I'm just saying
the design should be simple enough, and the replication costs, you know, you're talking $1,500 maybe, $1,500.
Yeah.
So it could be cheap enough and simple enough that you could imagine some hundreds of these being manufactured fairly quickly if it proves to actually be valuable.
Yeah.
I'm sorry, Peter.
No. I mean, I think that, yeah, there's the kind of the manufacturing at scale, and then also any regulatory improvements. It's one thing to be able to do a clinical testing, but then if you actually want to deploy this widely, I think you run into a lot of regulatory issues.
I mean, Axel his student got that thing you saw working in less than a week, sort of.
Yeah.
Okay, we have a broader question again on telerobotics. There's this guidance to position patients in a prone position in the intensive care unit. So does this compromise robotic teleassistance in general from your point of view?
I don't think so. I mean, I've heard about that, about positioning them in prone position, and in some cases in that, I think not even using a ventilator, but whatever medical device, and we're focusing on ventilators and infusion pumps because that's mostly what the need is for. So assuming you still have medical devices in the ICU that you want to remotely control, our solution would not be affected.
Okay, let me move on to maths. So there's actually two open science questions. So one is there any openly available structured data set that would link the type of treatment received by a patient to the outcome?
So this we do not know, but that's of course some of the things we're going to explore in the study. But there are no publicly available data on that, as far as I know.
And then the second question on this would be whether the code for the prediction algorithms that you are developing will be freely available, open source.
Yeah, so we plan to make a simpler version of it that is deployable outside the capital region that can be made available. That's part of the plan.
Okay. And then maybe before we move on back to the previous session, because we had to cut the questions very short, maybe one final question to all the speakers. Is there any pressing AI challenge that you perceive for the projects that you're handling? Anything that you would find particularly challenging for your projects?
I think in my case, there is a combination of, I mean, this is probably long down my line, but the combination of using data that is very noisy and very wild with perhaps some training data that isn't, and some ground truth that isn't, and the additional ability to bring this technology close to the user and on device is actually, I think, the next challenge for us.
In the short term, again, I don't think for the robotic thing that we're talking about right now, there's a huge AI challenge. I would expect that if something like this is successful, people are going to want more and more levels of automation. You might say, well, rather than push this button 8 times, you might want a command like increase the flow rate by such and such, and then the robot would go do that. And bridging that kind of human intent to what the machine does is, I think, an AI challenge. The other thing, in the longer term, we are going to see devices all computer networked, and this robot for this purpose will be not needed maybe 5 years from now. But then what you've got is a huge data stream of information coming from the ICU devices. And for that, there are huge needs or opportunities for AI. Already, there's some research, for instance, to predict when a patient is about to get in trouble and raise an alarm. So I personally, I think robotics has ignored nursing and ICUs too much in favor of surgery, which is, of course, what I've mostly worked in. So I think in the short term, no. In the medium to long term, lots.
Okay, so thanks to all the speakers of the final session again. And now I will hand over to Günther for the final questions and closing.